Just a quick reminder on doing this checkup, you need to make sure it's set equal to 0 before you determine A, B, and C and complete the quadratic formula. Section 8 talks about complex numbers. Complex number system itself is different than the real number systems that you're used to. Complex numbers are based upon a number whose square is -1. So if you take a look, we're going to talk about square roots for a couple of minutes. The square root of 16 is 4. Technically, the square root of 16 is plus or minus 4 because positive 4 times positive 4 is 16 and negative 4 times negative 4 is 16. The square root of 169 is 13 and negative 13 because 13 times 13 is 169 and negative 13 times negative 13 is 169. But take a look at number 3. The square root of negative 25 isn't something we're used to. 5 times 5 is positive 25. Negative 5 times negative 5 is still positive 25. Up until this point, we can't do a problem like number 3 because if the signs match, it's always going to force itself to become a positive product. So if that's a negative underneath the radical, we haven't been able to do that, but we can do that. This is where the complex number system comes in. So imaginary unit I is the complex number whose square is -1. There are two very important things for you to remember. The first is that I squared is -1. Anytime you have an I squared, you can replace it with a -1. And the second is that I is the square root of -1, which means when you have a negative under the radical, you can replace it with an I, which stands for the imaginary number. So I'm going to show you on the first one why this works the way that it does, and then after that you can kind of just use a shortcut. I can rewrite the square root of -9 as the square root of 9 times the square root of -1. The square root of 9 is 3, and I just told you, I'll come back to this in a second, that the square root of -1 is I. Anytime you have a negative under a radical, it's I. So I can replace that square root of -1 with an I. The square root of -9 is 3I. Essentially what happens is that negative comes out as an I and you take the root of whatever is left. So in number 2, the square root of -81 is 9I. 9 because the square root of 81 is 9 and I because you had a negative. Number 3, the square root of -36 is 6I. Anytime there's a negative under the radical, it's an imaginary unit. Pause the video to complete the U-tries. Just as a quick aside on something that's not on here, but you will see, if you had something like the square root of -8, fix the square root of 8 like we did earlier in the chapter. If you use the calculator or factor tree this, you should end up with 2 root 2. So you can write it as 2 root 2I, or more commonly, 2I root 2. Either is up to you. So the imaginary number unit itself has an I behind it. That's what makes it imaginary. If you take a real number and an imaginary number together, it's called a complex number. So the big idea behind this is that complex numbers have a real part and an imaginary part. 3 is a real number, and 5I is imaginary. If I combine them, like if I add them, it's a complex number. The real part gets written before the imaginary part. To add or subtract complex numbers, you combine the real parts and the imaginary parts separately. Kind of like you're used to combining like terms. So in number 1, if you take a look, they want me to add. It is super important that you see that plus sign because in a second that'll change. In order to add complex numbers, all you do is add the real parts. 4 plus 7 is 11. And then the imaginary parts. 3I plus 2I is 5I. Again, in number 2, we're adding. So the real parts, 5 plus a -1 is 4. And then the imaginary parts. -I plus a 5I is 4I. It's a little different when they're asking you to subtract, because in number 3, they want you to subtract. You kind of have to distribute that negative. What I really have is 8 plus 9I minus 4 minus 2I. And then once you do that, you can combine the real parts first. 8 minus 4 is 4. And then the imaginary parts. 9I minus 2I is 7I. So anytime you see that subtraction in there, just take a second to distribute the negative. I have -1 minus 3I minus 4 plus 6I. The real parts are -1 minus 4, which is -5. And the imaginary parts are -3i plus 6i, which is a positive 3i. If you're adding, just combine. If they're asking you to subtract complex numbers, you have to distribute the negative before you can combine imaginaries and reals separately. Pause the video to complete the U-triads. We're going to talk about multiplying complex numbers today as well, and it works with distribution, the way that you're used to foiling or distributing. If you take a look at number 1, 4i times 3i is a 12i squared. I'm not sure if you recall or not, but way back in the beginning, in fact, I'll find it for you, right here. Right here, I talked about the fact that when you have an I squared, it's really a -1. You should not leave any answers with a power on I higher than 1. So anytime you see an I squared, replace it with a -1. If I replace this I squared with a -1, what I really have is 12 times -1. So it's -12. All right, second one. I have to FOIL or double distribute. 5 times -1 is -5. 5 times 5i is 25i. -I times -1 is a positive I, and -I times a positive 5i is a -5i squared. Now I want to talk about that 5i squared part for a second. First of all, that term is negative, the term all the way on the end. If I take the I squared away and put a -1 there, that entire sign becomes a +5. The I squared goes away and I change signs. Once you do that, combine reals first, that cancels, and then imaginaries. 25i plus I is 26i. So you're going to FOIL, fix the I squared term, and then combine like terms. Number 3, I'm going to start by distributing. -1 times 4 is -4. -1 times -6i is a positive 6i. -3i times 4 is a -12i. And -3i times -6i is a positive 18i squared, which I'm immediately going to change to a -18. Change the sign, drop the I squared. I'm going to do the real parts first. -4 minus 18 is -22. 6i minus 12i is a -6i. Number 4. 4 times 2 is 8. 4 times 2i is 8i. 3i times 2 is 6i, and 3i times 2i is a positive 6i squared, which I'm immediately going to change to a -6. Change the sign, drop the I squared. Reals first. 8 minus 6 is 2. 8i plus 6i is 14i. Pause the video to complete the U-triads.